Scrap tires are one of the world's most troublesome solid waste problems. Every year, some 300 million pile up in the U.S. alone. Besides their sheer volume, the bulky discards present many problems in local landfills, creating a global challenge. Many end up in giant tire piles. In the U.S., there are more than 2 billion tires piled up around the country, making them one of the most serious solid waste problems ever encountered. The piles are not only an eyesore, they are an environmental nightmare. Dozens of these piles have caught fire, and since each tire contains at least 1 gallon of oil, the fires are almost impossible to extinguish. Some have burned for months, sending massive amounts of black smoke and dangerous particulate matter into the atmosphere, as well as contaminating groundwater. But this dilemma has a happy ending, thanks to the work of Charles McDonald, a former Phoenix City engineer. In the 1960s, he developed a way of blending scrap tire rubber with asphalt to create an improved paving material that is now known as asphalt rubber, and the subject of a standard from the American Society of Testing Materials. 30 years of laboratory and field testing has proven that his way of adding crumb rubber from old tires to conventional asphalt cement produces a pavement that lasts much longer. And that added durability is just one of the benefits of this remarkable paving material. Portland cement concrete pavement is a rigid surface, and conventional asphalt becomes brittle with age and oxidation. But the ground they cover is constantly expanding and contracting with temperature and other element changes. It doesn't take long for this underlying movement to produce cracks in these roadways. If not repaired quickly, the cracks grow to the point where the highway's subsurface is exposed to moisture, triggering more extensive damage. The advantage of asphalt rubber is its ability to provide a firm highway surface while remaining flexible in all climates. It provides a resistance to cracking that can double pavement life while reducing traffic noise and increasing tire traction for better safety. And it puts millions of scrap tires back to work. They are being diverted from landfills and tire piles for processing at plants like this. The steel is removed, and the rubber is chopped and ground into a fine granular material called crumb rubber, which is shipped to asphalt construction plants in large sacks. There, the crumb rubber is blended with asphalt cement under a time and temperature formula inside a large tank. It takes about an hour for the rubber to react with the asphalt to form an asphalt rubber binder. To qualify, according to the established ASTM standard, the blend must contain at least 15% rubber by weight, and the rubber must react with the hot asphalt enough to cause the rubber particles to swell. Standard practices of 20% plus or minus 2 of rubber produces optimum physical properties. The binder is tested in the field to meet specifications. It can be used as a spray-applied membrane or mixed with aggregate and sand to create an asphalt rubber hot mix. As a spray-applied membrane, it can be used for chip seals or interlayers to reduce reflective cracking. As a hot mix, it is placed with a paving machine, just like conventional asphalt, and transferred into pavers for application to the road surface and rolled smooth. With asphalt rubber, the road can be reopened to traffic as soon as it cools. In either case, the use of asphalt rubber has been steadily improved since its initial development. What started with 2 companies, 1 tire recycler, and a limited customer list has grown into a major global industry of recyclers, contractors, consulting engineers, asphalt suppliers, sealant producers, and equipment manufacturers. These firms have united as members of the Rubber Pavements Association to share this exploding technology with road building agencies and contractors throughout the world. The RPA maintains an extensive library of information on the development and proper usage of asphalt rubber and conducts many industry seminars and tours on the subject. Based in Arizona, the birthplace of asphalt rubber, the RPA can provide a unique look at all aspects of the process. From one of the country's largest tire recycling plants to contractors and highway agencies, well versed with the technology, as well as old and new examples of its use. When you look at the facts, the advantages of asphalt rubber are clear. Just putting an end to the dangerous tire piles and keeping scrap tires out of local landfills would be enough for many. But it's the engineering benefits of this paving material that make the biggest difference. You can produce a smoother roadway with better tire traction and less noise that lasts twice as long as conventional materials. And you only need half as much material to do the job. George Way is an engineer with the Arizona Department of Transportation.
When we first started to use asphalt rubber, it was primarily to address reflective cracking, and that's a form of distress on our pavements. Whether we used up one tire or a million tires really was not on our mind, and to be quite honest, it still is not necessarily on our mind. We know that using old tires is a good thing for the state of Arizona, but from the DOT perspective, we use them primarily because they perform very well on the pavement. That's the main reason.
That improved performance is also the key to understanding the costs of asphalt rubber. Initially, it can cost more per ton than conventional asphalt, but it's the total project cost that tells the story. On a section of Arizona's Interstate 40 near Flagstaff, at an elevation of about 7,000 feet, a 5-mile section was reconstructed in a conventional manner for a total cost of about $45 per square yard, and it took 2 years to complete. Later, an adjacent 10-mile section of the interstate was overlaid with asphalt rubber in just 4 months for a total of only $10 per square yard. After 9 years, the asphalt rubber section had no cracking. But in 10 years of service, the conventional section was so badly cracked that it had to be overlaid with asphalt rubber. Jose Morales, a former district engineer for the Texas Department of Transportation, has also seen the benefits of asphalt rubber.
As a department, we have to stretch our dollars as much as we can. We're sensitive to recycling, but that's just a benefit for the department. That is not the main reason or why we made our decision to, or for my decisions to stay with chrome rubber. All I gotta do is drive down the road and you see the difference where we have not done that. Those jobs look great. They're just 2 inches. It's not a lot of thickness there. There's people in other parts of the state that their mixes are a lot thicker than that, as you well know. But that we are using thin overlays, and we're still yielding good results. And we're talking 2-inch overlays on Interstate 20. Okay, so and we're still getting good results.
Whether it's high-volume interstates or neighborhood streets, more agencies are benefiting from asphalt rubber. In California, the city of Thousand Oaks has made it part of its street rehabilitation program.
Since 1991, we've been pretty much standardized on asphalt rubber hot mix, so all of our streets have been paved with asphalt rubber hot mix. The City Council has been very supportive of this program. They helped us initiate it in 1991 and really encouraged the use of this product, especially with the consideration of recycling the scrap tire component of it.
Through experience, highway agencies are learning that asphalt rubber is really the less expensive choice when everything is considered. Independent research has documented that when all the variables are taken into account, it is the best choice in more than 80% of all highway applications. The life cycle cost analysis is a support tool that highway agencies are encouraged to use by the Federal Highway Administration in analyzing alternative pavement design strategies. Such an analysis was conducted on asphalt rubber to qualify the long-term economic implications of initial pavement decisions. The study identified alternative maintenance and rehabilitation strategies and their expected lives, and included all costs incurred by an agency over the life of the project, from preliminary engineering to future maintenance. 3 scenarios used by the California Department of Transportation and their alternatives were examined. With a spray-applied membrane, asphalt rubber produces a savings of $4.11 per yard over conventional asphalt, With a thin hot mix asphalt overlay preservation, the savings for asphalt rubber climbed to $5.18 per yard. With a structural overlay, asphalt rubber saves $7.34 per yard over conventional asphalt. Performance data makes it clear that whether used as a stress-absorbing membrane, a membrane interlayer, an open-graded friction course, or a gap-graded application, an asphalt rubber binder provides much greater performance. And its application goes well beyond highway use to include airport runways, landfill liners, and many more uses. While many other modified asphalts are patented processes, the fact that asphalt rubber is a widely available public process assures agencies that they are paying fair market value for the product. With asphalt rubber, you get pavements that last twice as long with half the material. Motorists get a smoother, safer surface with less road noise. And everyone benefits from the elimination of dangerous tire piles and a reduction of landfilling volume. The test results tell the story, and the specifications are available today. That's why asphalt rubber is the pavement of choice for more and more agencies around the world. If you would like to learn more about the use and benefits of asphalt rubber, the Rubber Pavements Association can provide general information as well as specific responses to any questions on the subject. Contact the RPA and start improving highway quality as well as highway budgets while reducing the scrap tire problem. In every country and every climate, asphalt rubber can provide a dramatic improvement over conventional paving materials.